All right, so we're going to continue on with the binomial. I believe we did probably A through F on the last video. It was about 8 tires on a truck. Probability that any tire fails is 10%. So then we decided that OK tires was 90%. I started the lecture notes that I loaded for you with E, but I'm pretty sure this should be G. Okay. So this was also last time I gave you, maybe I should put that back up. Let's see. Part of the lecture notes, I had given you the mean and the standard deviation of the binomial. Okay, so we're going to need that for this part G. All right, so here is the question. What is the probability the number of tires that, you could call it pass or you could call it okay, whichever language you like better, that are okay, is within 1.3 standard deviations of the mean. So this is worded very differently. The problems used to be worded, what's the probability at least one fails, or, less than 5 fail, things like that. And we were using the PDFs and the CDFs last time. Well, there's nothing specific here. So we got to do some work before we ever get started. We got to figure out what the mean is, because it talks about the mean and it talks about the standard deviation, right? So the mean is n times p. So the probability, you got to be careful here. The probability of whatever is being asked in this problem, let me find a different color pen, is asking about okay tires. So we're going to use the 0.9 for the probability there. So you got to make sure you pick up the correct one. That gives you 7.2. And the standard deviation. And, well, now you're going to use both of the p's, so you don't even have to think about it. Don't forget to take the square root. And I'm going to double check my work. You stick that into your calculator too. Make sure you're okay with taking square roots. Yes, 0.8485. Now, that's the standard deviation, right? But this problem asked about being within 1.3 standard deviations. It didn't just say one standard deviation. The problem might, or a problem might say 2 standard deviations, so you'd multiply that by 2. This problem says 1.3 standard deviations. So why don't we go ahead and figure out what that is? That turns out to be 1.103. 1.1 would be plenty for you to be able to figure this out. Okay, so back to that language, within. Within in statistics means to jump up and jump down. Here's our mean. We're supposed to be jumping down 1.103, and we're supposed to be jumping up 1.103. What I'm doing right here is translating within 1.3 standard deviations from the mean. That, now don't round yet. This gives you, I'm being very precise just to show you exactly what numbers you should be getting, but we're about to change it all in just a second. Because this is the binomial, and when it comes down to it, you can't have 1.1 tires or 7.2 tires, right? At some point, we have to pull it back to the integers. So this is where you almost want to view, you are not rounding. This has absolutely nothing to do with rounding. You almost want to view these as goalposts on the number line. Or, I think I worded it pretty well on the lecture notes, what integers are between these numbers? 6 is not between it, right? So 7 and 8. We're not done, but I'm going to need to erase. These are the only 2 cases, and remember this whole problem was about passing, that we need to figure out. The 7 okay and or sorry, technically it's an or the 8 okay. So you're looking for what integers are between those numbers. You are not rounding. That's probably a common mistake here. All right, need some more room, so I'm going to erase. So we have figured out that we need case 7 and case 8. So we need the probability of 7 okay, 7 of the 8 tires, or plus we need the probability of 8 of them are being okay, right? So each one of these is a PDF. A cumulative really isn't going to help you here. The 7, okay. I don't know which 7, right? So I absolutely have to do binomial. And you're doing just the individual, not the cumulative. So make sure you pick the P. Now remember, old calculators, you have to put your N in. The probability you care about was about the okay probability, the 0.9, comma, and then how many do you need a 7. Again, if you have a newer calculator, it should be pretty intuitive where to put those 3 numbers on your screen. Now, you could easily do another PDF here, right? But last time we were talking about how sometimes you have the option. Do I have to do a binomial, or can I just do it what I called like the probability way that, you know, from a couple of videos ago? This is the all case. This is pretty much, there's only one way to do this, right? Okay, 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 8 times. 0.9 to the 8th. So that's how we did some basic problems when we first introduced the entire probability topic to you. But remember, you could do the PDF also, and you better get the same number. So this should give you 0.3826 plus 0.4305. Now you'll notice on the lecture notes I showed it as the PDF. So it does not matter. You have your choice. I'm going to check some math here real quick. Yep. And that will give you 0.8131. That's your answer, or 81.31%. So that was just to finish up the word problem. You know, those problems kind of look like test questions. I want to do something briefly now with coins. At some point on one of the videos, we talked about flipping coins and how, yeah, we know it's 50% heads, but there's a fallacy that some people think that that means they're supposed to get exactly 50%, and that's not the case at all. It's actually a pretty small probability. We're going to run some of those probabilities. All right, let's say we're going to do 10 flips of a coin, and this is assumed to be a fair coin, 10 flips. We want to know what is the probability we get exactly 5 heads. See, the thing is, I don't know which 5 heads, right? So, have to use a binomial, right? If it had said probability of 0 heads, or if it had said the probability of 10 heads, then you could just do basic probability raising to the power. But this one, I don't know which 5 you're talking about. There's tons of ways to do that. So absolutely have to do a binomial. It's just the singular because we're just running at 5. My n was 10 trials. My probability of a head was 0.5 because we assume it's a fair coin unless we're told otherwise. And then I was interested in getting 5 heads. That will give you 0.2461. So there's only, it's less than a 25% chance that you are actually going to get exactly 5 heads out of 10. Again, most people get between 4 and 6 heads. Less than a fourth would actually get exactly 5. Now, some people, this might sound a little counterintuitive. We had talked about the more you flip, the more accurate your empirical probability is, right? But with that said, it's a lower probability that you're going to get precisely 50% because there's so many other options, right? When you're flipping 10, you're either going to get heads 30% of the time, 40% of the time, 50% of the time, 60% of the time, right? It has to go by 10%. But with 100 flips, you could get it 39% of the time, 40% of the time, 41 or 42. So there's a lot more outcomes, right? So 100 flips, let's calculate the probability. You get precisely 50 heads, which of course is the 50%. So run your binomial PDF, and it's 100. Fair coin heads is 0.5, and we're going at 50. That will give you 0.0796. So, to talk about approximately 8% of the time you would get exactly 50 heads. Now, a lot of times in class, I'll when we're doing, particularly when we are actually in person, and, we're talking about flipping 100 times, I'll stand up there and make comments. Yes, most of you would get between 40% and 60% heads or something like that. Where am I pulling that from? How do I know that? Well, let's do something similar for part C. At the time when I do that in the classroom, I can't prove it to you because it's a binomial. Let's do this. Let's say we're going to flip 100 times. And we want the probability we get between, let's go with 35 to 65 heads. Okay, which is basically between 35% and 65% heads. Now, there's not a common way in the English language for people, when they read this, they never know if they're supposed to include the 35 and 65, and there really is no standard. When I say that, I do want you to include the 35 and the 65, okay? Wow, okay, we got a problem. There's like 31 different cases. I can't do 31 different PDFs or whatever, right? So this is when the cumulative is going to be critical, and we had done a little bit of that with the last video. Let's get the cumulative at 65. So there was 100 flips. A head is 0.5. I'm going to run it at 65, okay? But now think about what this just gave me. This gave me 65, 64, down, 35, 34, 27, 26, all the way down to 0, right? I did not want all of that. I wanted 65. I did want the 65 and the 64. I did want the 35. I did not want 34 downwards. That's not what I wanted. So, okay, we'll subtract it. Binomial, I'm just going to shorten it up so I don't lose you on the screen. I'm going to run it at 34. And we had briefly talked about that in the last video. Most common mistake on this problem is to put the 35 there. No, I do want the 35. So you have to jump down one and make sure you put it in at 34, because that basically gets rid of all of that I did not want. Stick that into your calculator. Don't round as you go. Make sure you end up with 0.9982 as the final answer. Yeah. All right, let's do one more problem. Okay, so yeah, I was trying to just kind of make up another problem that would sound like it's on a handout or a test or something. Pretty sure I stole this from the internet. takes 10 quizzes. This is the way her course is set up. Each quiz is pass-fail. And here's the rule that the professor gives. If she fails more than one quiz, she fails the class. Here's another given piece of information. Usually this piece of information is given to you at the beginning. I kind of just hid it in the word problem just to make you have to read more carefully. The probability of her failing any quiz is 10%. And we can assume it's independent. Whether she fails the first quiz has nothing to do with whether she fails the 9th quiz. What is the probability she passes the class? So do notice too, most of this info has been about her failing. We're asking for a probability of her passing. If you still need to copy this, pause me and write it down because I'm going to start talking about it. Okay, let's get some info though. Well, I don't want to have to keep reading all these words. Where's probability of her failing a quiz is 10%. So fail is 10%. Pass is 90%. She does have 10 quizzes. The probability she passes the class. Okay, well, let's think about this. That might be a little confusing because now I'm thinking in backwards way. So I'm trying to show you, as a student, maybe I've gotten a little confused here. Let me just do some more scratch work, right? All right, if she fails more than one, let's write out what that means. If she fails more than one, so that would be, so she's going to fail the class if she fails 2 or 3 or 4 or all 10 quizzes, right? That's the definition of failing the class, okay? Well, then anything else is passing the class. Oh, okay, so passing the class means she can fail 0 or fail 1 quiz, right? Because if she fails more than one, she fails the class. Well, then that means she'll pass the class, right? If she fails 0 of the quizzes or 1 of the quizzes. So the one thing, I think this is why I pulled this off the internet, it's a little hard for me to read because we're talking about passing and failing quizzes, but then we are also talking about the bigger idea of passing or failing the class. So that's why I started, clarifying a little bit just in case you were getting confused. I would encourage you to do that also. Because the question is, what is the probability she passes the class? Passing the class means she can fail 0 of the quizzes or fails 1 of the quizzes. This is what we got to calculate the probability on. Now, of course, I might be able to squeeze this in. Oh, this is nice. Okay, let's talk about that. There's probably 4 ways you could do this problem, right? You could do binomial PDF there plus binomial PDF there. Actually, this guy, you don't have to do a PDF because it's the 0 case. So you could do binomial PDF here plus, well, you'd have to change that to all pass. So I've already listed 2 different ways you could do this. The 3rd way is the easiest though. Remember our cumulative? The cumulative definition is if we run it a cumulative at 1, it's going to do the 1 case and the 0 case and add it up. That's exactly what I want. So we're going to run binom CDF for the cumulative. I had 10 quizzes. Now remember, I don't care that this is about passing the class. We are trying to figure out the probabilities of failing 0 quizzes, failing 1 quiz. Fail. You have to use 0.1 here because that represents the fail, and then 1 because it's going to do the 1 case and it's going to do the 0 case since I'm doing the CDF. 0.7361. So, not bad. All right, so this was give you a few extra problems to look at, but particularly to practice that mean and standard deviation. Those problems really jump out at you. There are a couple on that second page of handout 19, so make sure you practice those. And this does wrap up the binomial and this entire topic.